In this video, we will be looking at more of evolving patterns features, including the random output and CV control. This is mostly the same patch as in the previous video. We have evolving patterns with its gate output controlling an ADSR envelope and an oscillator going through a filter. We also have the random output of evolving patterns routed as a modulation source for the filter's cutoff frequency. These charts on screen show the gate signal at the top with the random signal below. For the random signal, we have an output of around 0 to plus 5 volts. We adjust the filter frequency and start to increase the influence of the random modulation. As you can hear, we get a repeating signal. As with gate patterns, we can use the evolution knob to dial in the rate of change with the sequence, between identical repetitions and full randomness. If we reduce the density so that we don't open the gate on each clock pulse, we can see from the chart that we only get a new level at the random output on the clock pulses where the gate triggers. Let's take a closer look at some of the inputs. In the lower left, we have the clock input, which we have been using, and an input for a reset signal. As expected, we can use this reset signal to start the sequence over from its first step. Here we have it connected to an LFO, giving us a square signal. Let's see what happens. Another feature is the enable input. As we have until now, this can be left unconnected, but if needed, it can be used to turn on and off the possibility of getting gate signals out. When it's not enabled, the sequence still gets clocked through its steps. This input gives you a chance to control when you want the model to take effect. Typically, you would have an external clock you want to use for the module to synchronize with. But as an extra feature, the module does have an internal clock as well. If you simply leave the clock jack unconnected, this will take effect. Of course, the rate we get from just that may not be what you want. There is a way to change the rates. We simply take a signal which has the desired rate, plug it into the reset jack, and make sure we get a few pulses to sync up the rate. Now, the external signal can be removed and changed, and the internal clock will keep the module ticking at the chosen rate. Now, let's look at the rest of the input jacks. These are for CV control of the effects of the sliders and knobs. They all work the same. The res1 and the reach slider and the evolution and density jacks are on the lower left side. Before we use these, I want to mention something about calibration. The module is shipped ready for use, so you usually don't have to do this, but if you think you need it, you can calibrate the module by leaving all of the inputs unconnected and holding down both of the buttons at the same time while turning on the power to the system. These CV inputs are additive, meaning that we take the value from the knob slider, add the voltage from the CV input, and use that to drive the module. The full range of a knob slider corresponds to about 5 volts, and the CV control works in both the positive and negative direction. You may want to use an external attenuator to control how much modulation you get. For example, we can use an LFO to control the density of the gate sequence. Or we can have it modulate the gate length. That concludes the features covered in this video. We hope you can find interesting ways of making use of all of this in your own patches, and we may return in a later video to give you some more ideas.